Hello everyone, myself Tejas here. Today I will be giving to you a practical demo on big data tools. This demo is based upon my AI project, which was a contextual chatbot. Because of time constraints, I will not be discussing about it here. But from the data point of view, the question which I pose to the chatbot and the answer which I get back from the chatbot will form the data here. And what happens with this data is that this data will be passed on to Cassandra using Kafka, and then we will use Spark to retrieve that data which is stored in Cassandra and analyze it. So the demo deliverables would be a Cassandra demo, a description about HBase, Kafka demo, then an explanation of the project which involves DNS resolution, Cassandra Sync API, PySpark, and Docker. Finally, I would be giving to you the demo of the entire project on Gitpod. So now let me move on to the next section. So what exactly is Cassandra? Cassandra is a distributed NoSQL database. The installation procedure of Cassandra is similar to that of Hadoop and Spark. We will download the zip, we will extract it, we will go inside the extracted folder and open a terminal. However, we don't need to use any bash script. Directly in the terminal, we will type in the command bin/Cassandra. So this will launch the Cassandra server. Once the server is launched, we will type in the command bin/CQLSH. So CQLSH stands for Cassandra Query Language Shell. So this is similar to that of MySQL, MySQL-u root-p. So this will open a shell where we can execute the Cassandra queries. So now let me perform the execution of few simple commands in the Cassandra shell. So this is the Cassandra. As you can see, the server has started here, and this is the Cassandra prompt. So here I will be executing few simple Cassandra commands. So first, let me begin by checking what are the key spaces that are available in the Cassandra. So what exactly is a key space? So a key space is the equivalent of a MySQL database. So now if I give describe key spaces, so you can see that these are the key spaces that are already available in Cassandra. Now, what if I want to create my own key space?
So type that in a notepad first on the text editor and then copy the command because it's not easy.
Let's see if I can zoom it. Is it visible? Or should I enlarge? This is better? One more. I think now it's there. So this is the Cassandra shell where we will be executing the Cassandra queries. So I executed a simple command which is called describe key spaces, which will list the key spaces that are already available in the Cassandra server. So key space is the equivalent of a MySQL database. So now let me create my own key space. For that I will just use this command, create key space. So I will copy this command and I'll paste it. Let me go to home and see. So create key space. So already there is a key space known as chat key space. So let me give another name for this. So let us say chat one key space. So now if I click on enter, a key space has been created. So now let me verify if the key space has indeed been created using describe key spaces. So you can see that we have created our own key space which is named as chat1 key space. So you can see that there is something known as with replication. So in this tutorial it does not make much sense because it's just one node, but in practical environments we will have more than one node. So a node means a machine. So if we have multiple nodes, then we will specify the replication factor which is other than 1, maybe 2 or 3, depending on the number of machines. And the strategy is nothing but the manner in which we will perform replication of the data in the cluster. So in this tutorial, it does not matter much because we have just one node. The next process would be to create a table. Now before I create the table, so similar to MySQL, I must first use the key space. So I use chat1 key space. So now you can see that I am using the chat1 key space. So in this key space now I will create a table, and this procedure is similar to that of MySQL. So now let me create table. So let me say chat1 table, and I will have 2 columns. Let me say ID and name. So for that, let us say ID has data type int, and I'll make this as the primary key. So primary key, and I'll specify one more column, say name, whose type is varchar. So like this, I'll create the table. So it's been created. Let me verify if the table has been created using describe tables. So you can see that chat1 table has been created successfully. The next step would be to insert few one data into the table. So for that, once again, it is similar to that of MySQL. Insert into chat1 table. I'll specify the columns, ID and name, and then I'll say values, and I'll give some value. So let us say 1 and tails. So one point to be noted is that there is no double quotation in Cassandra. So you must always specify single quotation. So I'm giving the one value to this. So it's been inserted. So the final step in this would be to just query the data. So for querying the data, I'll just use select star from chat1 table. So you can see that the data which was inserted has been retrieved successfully using the select query. So now let me move on to the presentation. Yeah. So it looks like, from the broad perspective, it looks like it's very similar to RDBMS. However, there are a lot of differences between Cassandra and traditional RDBMS because of the architecture. So Cassandra is meant for distributed systems. So it's not like we can run all the queries in Cassandra also. So there will be a lot of differences which will be discussed in the coming labs. So right now, because of time constraints, I am going to the next section. Now HBase. Once again, HBase is a distributed NoSQL database, but unlike Cassandra, it is meant for fast read and write operations. So how fast? So just imagine you have 2 billion records and you want to access just 50 of them. So if you use Cassandra for this task, it would take maybe some 30 minutes or 20 minutes, but HBase can do that in maybe in seconds. So that fast. So this is what HBase is meant for. It is meant for operations, read and write operations with high throughput and low latency. And the distinguishing feature of HBase is that we have direct Hadoop HDFS support. So this HBase will run on top of Hadoop. And the creation and the installation of HBase is extremely simple. So due to time constraints, I'll be skipping that procedure here. It is extremely simple. So to create a table is as simple as this. So we'll say create table name, some table name we can give, and if we can give as many columns as we want. So column 1, column 2, column 3, etc. And if we want to perform a write, we just use the put command. So we have put followed by the table name, and we have 1. What is this 1? It represents the row number. So I'll insert into the row number 1, and this is the column name. Since this is a NoSQL database, I can divide the column into as many parts as I want. So what I did here is that personal data is the column. I divided it into one part known as name. So I can have personal data age, personal data salary, I can have any number of partitions. So in this partition called name, I am storing the value known as Raju. If I want to retrieve that, I simply use the get command. This procedure is similar. The next procedure would be that I am performing a get operation. So I have to specify the column. So what is the column? It is personal data. and under which partition you want the data, it is named. So the result of this operation would be nothing but rather. So using just this much, we can have a very fast read and write operations through Headspace. Now let me go to Kafka. So Kafka is a distributed event store. So what exactly is an event store? So as the name suggests, it is used for storing event-related information. So we know the producer-consumer pattern. Producers will write something to the buffer while consumers will read something from the buffer. So in Kafka terminology, what happens is that we have the topic as a buffer. Topic is something to which the producer will write and the consumer will read from. So now let me directly give the Kafka demo. Yeah. So I'm running two servers here, Zookeeper and Kafka. Now let me execute few simple commands in Kafka. So as I told that topic is the central concept of Kafka. So first step is to create a topic. So for creating a topic, I'll say bin slash Kafka topics .sh, and because I want to create a topic, I'll specify the option as create. And let me give the topic name as quick start events. And one important point here is that any Kafka command we use, we should always specify the, oh, you want to find it. Better? Yeah, so always we'll specify one important option, which is bootstrap server. So what is this bootstrap server? This is used to mention the location of the server, where it is running. So since it is on the same machine, we are saying localhost followed by the port number, which is 9092. So now let me create this topic. So you can see that the topic has been created. Now if we want to verify whether the topic exists or not, I'll be making use of the same command with a different option. So instead of saying create, I will say list. I will say list. So now what this command does is that it will list the topics which are present in the Kafka server. You can see that the topic which I created has indeed been verified. Now, as I told that producer and consumer is the pattern, the first step would be to create a consumer so that we can verify all the messages being written to the topic. So how do I create a consumer? For that, let me type bin slash Kafka. Yeah, so this is the command. So what this command does is that I'll create a Kafka consumer which will read from the topic quick start events, and I specify from beginning so that all the events which I write to the topic will be visible to you. And now if I run this command, it will not show anything initially because there's nothing been inserted. So if I want to insert something, I have to call the producer. So how do I call the producer? So for that I am going to use the command Kafka console producer. So now what this does is that it will write messages to the topic. So now if I press enter, so you can see there's a greater than symbol coming here. So you can see this. So what this means is that I can now begin typing messages. So now very carefully follow the right terminal, and as I type in the messages, there will be something that will happen there. So now let me type hello. So you can see that the event appeared in the consumer. So as and when I give messages to the producer, it will be present in the consumer. So hello, I am Tejas. So this is the utility of Kafka, that is, we have an asynchronous event read-write mechanism. So this is very useful in microservices where we have to perform communication between various services. So one service will write to one topic and the other will read from the topic. So this was all about Kafka, and now let me proceed with the presentation. Yeah, so I won't be discussing with the chatbot, but the thing is that this is the simple architecture. So front end and the back end. So what happens is that we give the question to the back end using the front end. The model will give the answer for it. So what happens is that this question answer will be forming the data, which will be passed on to the Kafka server. So how exactly we will pass that? So that will be done using the Kafka client. So Kafka client is a library which connects Python to Kafka server. So one small quiz. So in this case, backend is a consumer or a producer. As I told that backend is responsible for generating the data. So now think whether it is consumer or producer. Yeah. Since it is a producer, the code for the Kafka client is as follows. So what we do is we create a Kafka producer object and we will write into the topic. So obviously this library wants a Kafka server to be running on the port, but what if that server is on a different machine? So what happens is that Kafka wants hostname, but I give the IP. So how do I get the hostname using the IP? So what does this concept remind us of? That is address hostname. This concept, what does it remind us of? DNS. And one more thing, which file is responsible for DNS configuration? So this was there in the Docker tutorial, if you remember. So it is etc/hosts. So Kafka to Cassandra is the next part. We will be using an API called Kafka Cassandra connector. Installation procedure is the same. We will download the zip, we will extract it. However, the configuration procedure for it is very lengthy. So I'll be going to the next part. The next part would be to connect Spark to Cassandra. So what happens is that the tutorials will suggest using Spark submit. So this is the one which we use in our big data lab. So this requires Spark installation. But there is a convenient thing known as PySpark. PySpark will build its own Spark session without us having to install Spark. So instead of using Spark and Cassandra, we can directly use PySpark and Cassandra. So once again, we are using DataStax connector for performing the connection. And now Docker. So why exactly Docker here? Suppose I wanted to share my project with somebody else. I can share my Python up with them because they just install the dependencies and there is nothing. But what about this entire big pipeline? They have to do the downloading, extracting, configuration, they have to run the servers and connect those servers and also connect PySpark to Cassandra. So which would be too much of work. So what I'll do is that I'll simply Dockerize my entire pipeline and I'll create an image. How to create an image? The best way is Dockerfile. I'll write all the instructions within the Dockerfile and I'll produce the image. So why I kept this picture is that many people suggest using Docker commit. So they say that you have a container, you can create an image from the container. But Dockerfile is good for this purpose because it allows us to manage images in a document table and maintainable way. So if our requirements change even a bit, the Docker commit will simply produce static image. It won't be changing. So in this case, Dockerfile is very useful. And one golden lesson which I learned during the project was that as far as possible use scripts while using the Docker. And finally, a demo of this project on Gitpod. So what exactly is Gitpod? Gitpod provides us a cloud-based development environment where we can deploy and test our applications. So one small quiz. Which service model do you think Gitpod uses? Is it IaaS, PaaS or SaaS? Because it's for application development. So it's platform as a service. And as the name suggests, it's going to create something upon Git repository, and that environment is based upon an IDE known as like PyCharm or Visual Studio Code. So now let me finally give the demo of the project on Gitpod. So this is how Gitpod looks like. Now I'll create a workspace. So it's asking me to give a URL. I'll paste this. So you can see that these are the features that will be provided by the development environment. So now if I click on continue, so now what this does is that it will create a development environment based on my GitHub repository. So you can see that to the right, to the left of this window we have the repository, and here we have the terminal where we can type in the commands, and this is the VS Code. So now for this project I have created an instructions file which I will be using. So now let me start the procedure. I'll just copy paste this. So now the next step would be to install the dependencies. So you can see that the dependencies have been installed. Now the next part is why I had told about the host file. So what I do here is that since I had dockerized my application, the Kafka client is not smart enough to know that Kafka server is running inside a Docker container. So I have to tell that, look, my Kafka server is inside the container. So you remember this entry. So what is this entry? My Docker container's name is Kali and it is running in localhost. So I put this entry into the host file so that whenever Kafka client will try to recognize things, it will find that, okay, this Kafka server is running in a container known as Kali. So that's the purpose. I'll copy this entry. I'll wait for the procedure to complete, and after that I will, so now I will type in the command sudo, because the host file is read only, so I must have super user privileges. So /etc/locals. So you can see that these are the entries in the host file. So now let me add my entry to this. So I have added the entry. So now Kafka client will know that there is a container known as Kali. So you can give any name for it. Now let me run this command. So as you can see, it is going to pull an image from the Docker Hub. So this is my image which is present in Docker Hub. I'll pull it from there. I will name my container as Kali. I'll expose the ports. So this is for the Cassandra and this is for Kafka. So I'm exposing the ports, and I'm also giving a specific IP because it helps when I'm performing the Kafka Cassandra connection. So this is the pulling procedure. The image will be downloaded, and as soon as the image is downloaded, the scripts will start. So as I said that during Dockerfile, use scripts as much as possible. So you can see that this is the result of the script. I have started the Cassandra server. So all this is being made automatic because I use scripts. So all this is because of Cassandra. So you can see that I used a special script which automatically created a key space. So you can see this is the name of my key space. And I also created a table. So what I did is that I put some wait so that between the waits I'll launch the servers. Because if we launch the servers all at once, there will be race condition. So I'm going to put a wait so that one after the other the servers will be launched. Finally, in some time we will see that there will be the Kafka Cassandra connector starting. So in a few seconds it will start. So what's happening is that, see now you can see. So this is the Kafka Cassandra connector. So because I had launched the Kafka Cassandra connector, I had launched the servers before. Now you can see that See, this is the thing. This is the topic which I created. Now I connected the Cassandra to that topic. So next step would be So now let me go to the next section of this. So I'll make a small change to my file, which is necessary because I want to deploy it. So you can see that here 81 is there. I'll make it as 105 because this is the URL which is present in my Git form. So now I made it as 105. Now what I should do is I'll go to the big data folder and run this file. So I'm going to run this file. So you can see what happens when I run this file. So it's initiating TensorFlow and it's using NLP. So this is the training procedure. Within 10 seconds the training procedure is complete. So entire chatbot is being trained from scratch. Training is done. So now I have to run the Flask app. So this is my Python backend. So you can see that all this is from Kafka. So because I use the Kafka client library, this is all the information that's being logged here. So it's saying that there's a service available on port 5000. Let me make it public. So you can see that there's a service running on port 5000. Let me click on this. Yeah, so this is the chatbot. Now let me type in some question. So let me say who is the developer? Who is the developer? So you can see that it's giving a response. So now what happens is that this question and answer will be giving the data. So I have to retrieve that data using Spark. So this is the final phase of the project. Now what I should do is I'll go here and I'll run the file which is responsible for the Spark connection. So here what happens is that PySpark will connect to Cassandra and it will fetch the data which was there in Cassandra. So in few seconds it will show the table. Yeah, so you can see, right? This was the question which I gave to the chatbot and this is the answer. So what happened in the backend was that I gave the data to Kafka. Kafka gave it to Cassandra and then Cassandra gave it to Spark. So this much of work is happening in the backend. Let me type one more question. Let me say, tell me about website. So it gave one more answer. Now this question and answer, once again it will form the data. Now let me check whether I can retrieve it successfully. So I will once again run this file. Yeah. So you can see that as and when I'm giving the data into the chatbot, it's going to Kafka and then to Cassandra and then to Spark. So this was the demonstration of the entire project, which not only gave you the ideas about HBase, Cassandra, which will be part of the lab, it also gave knowledge about tools such as Kafka, which is useful in microservices. It also gave an idea that how we can build big data tools for backend. So thank you one and all for your patience.